Well, how's everybody doing out there? So for the next section, we're going to be looking at testing a claim with two proportions. So this is going to be very similar to what we did in section 8.6. So the one new thing that we haven't had before, because we're dealing with two proportions, is we want to actually form what's called a pooled proportion as a way to take these two separate proportions, bring them together to talk about a single proportion of how these guys are related together. So if we look at the way our P pooled is formed, is what we're doing is we're taking our P1 hat, which would be x1 over n1, and our P2 hat, which is going to be x2 over n2, and we're actually combining them together by adding the two x values together, adding the two n values together, and then dividing and see what proportion that we actually get. And so where we're going to use our P pooled is down here when we're going to find our test statistic. And so notice at the same time, we're going to find our 1 minus P pooled, or if you want, you could think of this as Q pooled in this case. All right, so again, we'll get to that in just a little bit. So our hypotheses are exactly the same as since the last two sections, except we've swapped out our mu for our P1 and our P2, our different population proportions. Our test statistic starts off kind of the same way. So we've got our P1 hat minus P2 hat. But then when we divide it by, instead of using our sample standard deviations like we did before, we're using these P pooled and the 1 minus P pooled, which is related to our standard deviations if you remember from back in 8.6. And then again, we're multiplying that by 1 over n plus n1 plus 1 over n2. And then our ZC is going to be our inverse norm. And again, it's either going to be alpha or alpha over 2, depending on whether it's a one-tailed or a two-tailed test. And since, again, we're working with z-scores, we're back to using the mean and standard deviation. So we need our 0 and our 1 for those. All right, so for our calculating the p-value, this is exactly the same as what we did in 9.1. So on our two-tailed test, we're going to have our normal CDF, but again, we do want to remember to multiply that by 2. For our one-tailed test, we just treat them like normal. We don't have to worry about multiplying anything by 2. And then finally, our conclusion, same as what we've been doing. If p is less than alpha, we reject h naught. If p is greater than alpha, we're going to fail to reject h naught. All right, so let's dive in. Let's take a look at an example to see how we do here. So the National Health and Nutrition Examination Survey weighed a sample of 546 boys and found that 87 of them were overweight. They weighed a sample of 508 girls and found that 74 of them were overweight. Can you conclude that the proportion of boys who are overweight differs from the proportion of girls who are overweight? So for this one, I'm going to go ahead and think of P1 as the boys and P2 as the girls, since that's the order they came in the sentence. So let's go ahead and identify all the different pieces that we have. So our X1 is going to be our 87 boys. Our N1 is going to be our 546 boys. So our P1 hat is going to be 87 over 546. If we type that into the calculator, looks like we get 0.159 for our P1 hat. And then for our X2, we had 74. For our N2, we had 508. And for our P2 hat, we've got 74 and 508. So it looks like 0.146. All right, so now that we've got our two sample proportions, so let's go ahead and calculate our p pooled while we're at it here. So our p pooled, which I'm going to abbreviate as pp, is going to be our x1, which is our 87, plus our x2, which is 74, all divided by our n1, and then our n2. So if we plug this in the calculator, we will get our p pooled. So we've got 87 plus 74 divided by 546 plus 508. And so our p pooled appears to be 0.153. All right. So with that in mind, let's go ahead and figure out our Q pooled. So that's just going to be 1 minus 0.153. So when we do that, 1 minus 0.153, we end up with 0.847. All right, so now we have all the background information we need to be able to do all of our different test statistics. So first thing, let's go ahead and find our claim. So our claim is in this last statement. So can we conclude that the proportion of boys who are overweight differs from the proportion of girls who are overweight? So again, differs is going to be a equals not equals situation. So P1 is not equal to P2. H naught is P1 is equal to P2. All right. So let's go ahead and calculate our test statistic. So we're going to have so I'm just going to write it up here again to remind us. So P1 hat minus P2 hat divided by the square root of PP times QP all times 1 over N1 plus 1 over N2. All right, so we've got our P1 hat is 0.159 minus our P2, which is 0.146, all divided by the square root of 0.153 times our 0.847, all divided by 1 over 546 plus 1 over 508. So this is ugly to look at, and probably just as equally ugly to type in the calculator. So we definitely want to be careful when we type this in to make sure we don't make any mistakes or anything like that. So let me flip over the calculator here and try my best. So we've got our 0.159 minus our 0.146 divided by the square root of our 0.153 times our 0.847 times parentheses our 1 divided by 546 plus 1 divided by 508. So I'll leave that up there for a second just so everybody can see how ugly it is and what it should look like when we type it in. And so when we hit enter, looks like we're going to get 0.586 for our z sub t. So 0.586. All right. So now let's go ahead and focus on our z comparison. So with this one, it looks like no alpha was given. So that tells us that our alpha is going to be 0.05. But since this is a two-tailed test, we're going to want to divide this by 2. So we're going to need to plug in 0.025 as our probability, and then 0, 1. So let's type this in. 0.025, 0, 1. So it looks like we've got negative 1.96. And so since it's a two-tailed test, we do want to use both versions of these. So we want to use negative 1.96 and positive 1.96. And so again, just like before, if we're in the blue, we're going to reject H naught. And if we're in the white, we're going to fail to reject H naught. And so our Z of t is going to fall somewhere around here with our 0.586. So it looks like we're clearly going to be in the white section. So it looks like we're going to fail to reject H naught. All right, so let's calculate our p-value. So we're going to get normal CDF. And since, again, this is a two-tailed test, but our 0.586 is to the right of 0, we're going to think of this as the upper or the lower bound. And some ridiculously big number is our upper bound, 0, 1. And then we want to multiply this by 2, which I forgot to do in the last video, which I will fix at some point in time. And so now let's type this in the calculator to see what we get. Oops, not inverse norm. 0.586, comma, some ridiculously big number, comma, 0, 1. And then multiply that times 2 since it's two-tailed. So we end up with 0.558, which is not a very low probability what's day of the week. That's pretty reasonable. So that's definitely bigger than our 0.05. So again, we're going to fail to reject H naught. So it supports our claim from above, which is perfect. So it looks like our conclusion is that we've failed to reject the claim. So there is not sufficient evidence to support the claim that being overweight differs between boys and girls. All right, so perfect. So again, I've got a few different practice problems here. So I'm going to do like we did before. I'm going to divide them up amongst groups. And then for the homework's actually going to come from 9.4. There's a bunch of different practice problems here, but I'll post the ones that I'm interested in you guys doing for the homework. So definitely reach out to me if you have any questions or if you're having any problems or anything. Otherwise, good luck with our hypothesis testing.